Hey everybody, this is part 2 of section 1.6. I've just got 2 more examples to do. The first one was very, very intense. This one's not going to be so much. All right. What we got here is a triangle in which this part goes to the center, the base of the rectangle goes to the center of the circle, in which we're supposed to determine the area of this shaded region. If the circle, the only thing we know is that this circle has a radius of 12 centimeters. Which means we know that that distance right there is 12, and this distance right here is 12 as well. So here's what we do. We're going to say, if I find the area of the big shape, circle, right? And I take out the area of that middle triangle shape through subtraction, I'm going to come up with that shaded area that they're looking for. So here's how we do it. The area of a circle, if you scroll up to our formula sheet, will be pi times r squared. The area of the rectangle will be 1/2 times base of the rectangle times the height of the rectangle. Pi, we're going to use 3.14. We know that the radius is 12 centimeters, so we don't have to mess with the diameter and cutting in half. Just plug in the 12 right away. And then the base. See, the base of the circle isn't given to us. I'm sorry, not the base of the circle, the base of the triangle. But think about this. What does a radius represent? The radius represents half the distance of the diameter. What is the diameter as it relates to this triangle? It's the whole base. The base is 12 plus 12. The base is 24. The height in this case is another radius. It's also 12. All right. Hopefully you guys are making sense of that. By the way, I am operating under the assumption that this is a right angle. Okay, so I probably kind of overlooked that a little bit, but it is a right angle. So, how do we work our way through this? Well, we can do each individual area kind of independent of one another, right? Like we can figure out what this is, figure out what this is kind of at the same time. So take 1/2 times 24. You get 12, right? So that's just going to be 12 times 12. That's going to be 144. Now you also got a 12 times 12 here. That 12 squared has to come first in this area. So you're going to have 3.14 times 144 here. And of course, we're going to eventually subtract 144 from that. So 3.14 times 144. All right, we're back to a 3-digit times a 3-digit. You might want to just pause the video and see if you can do this without me showing you. All right, let's see what you got. First row should be 1256. Second row should be 12,560. And then 31400 should be the final row. Add your columns and you get 452.16 minus 144. At this point, I'm just going to stack the 144 underneath it. Remember to line up your decimals. Otherwise, bad things will probably happen in computations. So 6 minus 0 is 6. 1 minus 0 is 1. 2 can't take away 4 unless you borrow from this previous one, so it's 12 now, which meant I borrowed from the 5 to the 4. 0, 3. Okay, we've got an answer. It's 308.16. Area is square, centimeters. I actually have an alternate way of doing this calculation that's pretty nifty. I might show it in class. We'll see. All right, next one. All right, we got an interesting story problem. Jeremy has finally decided to paint his living room wall a heather gray color. It has somewhat funky dimensions with 3 rectangular walls measuring 25 by 12 feet each, and 1 remaining rectangular wall measuring 12 feet by 20 feet. Okay, so just to kind of put this in context, we've got 3 rectangular walls that go 25 by 12. So it's like 25 by 12, 25 by 12, 25 by 12. And we also have one that goes 12 by 20. This is not drawn to scale, so yeah. On average, 1 can of this particular paint can cover 80 square feet. So 1 can of paint equals 80 square feet. All right, so how many cans of paint does he need to buy to complete this painting project without, overspending like crazy? You don't want to buy less paint than what you need, but you certainly don't want to buy like 3, 4, 5 cans more than you need. So here's what we do. We need to find the square area of all of these combined. So here's what I'm going to do. I'm going to find the area of this first wall and then just multiply it by 3. So length times width, 25 times 12. All right, that gives me 50. All right, so 300 square feet for that first one times 3. Times 3 walls is 900 square feet. Now this one needs to be added onto it. So that just drops a 0 down to, 2 times 2 is 4. That's 240 square feet. So I'm adding on the 2, sorry, it's hard to see that, isn't it? 240. So you're adding on 240 square feet. So the total space in which not me, it's Jeremy here, whoever Jeremy is responsible. 900 plus 240. That's 1,140 square feet that needs to be painted. So if 1 can only covers 80 square feet, we got to take this and divide it by 80. $80 goes into 114 one time. 114 minus 80 is 34. Drop the 0. 80 is going to go into 340 4 times. You get 320. And there's 20 left over. Now 20 divided by 80 is our leftovers. 20 left over 80. 20, 40, 60, 80. It's 1/4. All right? So it's 14 and 1/4. Now, I can't really buy a fourth of a can of paint, so I'm guessing at this point we would probably say 14 and 1/4 cans are needed. So Jeremy should buy 15 cans of paint. Sorry, I keep cutting you off. All right, you know what? I made all these examples in one way or another particularly challenging with the calculations. All right, I believe that they're way more rigorous than the actual homework problems. So try not to be too disheartened by the fact that that number one example, A and B, was just really, really tough. So yeah, hope this is helpful, and I'll see you later.